Hi, this is Shakil Ahmed. In this tutorial, we will discuss about parameter estimation for different parameter distribution using optimum function. We basically find the estimates of the parameters using different methods, and one of the most widely used method is maximum likelihood estimation method. And in real world, when we have complex uh, when we have a data set of complex nature and we want to fit on for a given distribution and we don't know about the exact form of the MLE and we have just have the distribution, a theoretical distribution, and we have a real data. So we want to estimate the parameters of that distribution and that hypothetical distribution for which we want to uh, fit our data. So we have a Poisson distribution with the observations and frequencies. You can just write your observations and then these are the frequencies corresponding to these observations. You can just run, and if you see the distribution, there are a lot of ones, and if using plot function, uh, plot after making x table of x. Table of x means you are just uh, plotting frequencies versus values. And these are the values and these are the frequencies. And you can, this is a line plot, just points, and these are the x values and these are the frequencies. And this is a Poisson distribution with different cones. And we are interested in finding the parameter of the Poisson distribution, that is the red parameter lambda. And for that, we use the optimal function. So we just need to create a function that is called log likelihood. You just here, and this is a likelihood of Poisson. That is function of x and lambda. Lambda is basically the initial, we need to give some initial value of the lambda. And then this is the function of likelihood. That is x time or lambda minus log of x factorial minus lambda. Basically, the likelihood function is uh, e power minus lambda. When we take log, it will just we just left with minus lambda, and then lambda is power x. So x and log of lambda, and in division we have log of x factorial. So I have just written the likelihood in terms of log, and then we need to maximize this likelihood value. So instead of maximizing the optimum function, minimize the given function. So you just need to use a minus sign with the sum of with the log likelihood. This is log likelihood, and I'm just putting a minus sign so that the function we get the maximum value of the function. So we can just use the optimum function again. Results, result, and then optimum parameter. Initial value of parameter is I have taken a 2. If you want to take 0, you can take 0, and then x is equal to the x as we have the table. So basically the input is x and the parameter is 0 and the function is log likelihood. You can just run this. You need to write the function first. I think I have not write the function and apply the. This is not working as the log of 0 will not work, so we need to write some value which give the uh, as we can get some when you take the log, it will give some positive value. So this is by default it uses the Melt's method. So this method is unreliable. So you can use other methods as we discussed previously, but it should give some result. If we just see uh, the convergence is achieved already, and this is the value of the maximum likelihood, and the parameter value is 2.71. That is the optimum value of the lambda. So that's all about the estimation of uh, parameter in using the optimum function. So you need to just define the function here, and then you need to give the inputs, and the optimum function will consist of the initial values of the parameters and the function we have defined here, and then the data you need. So you need to just give this input, and then we can just run the result. And if you want to use different other methods, then we can just optima and help. You have different methods. For example, I will use BFGS method as the as by default it uses the Nelder-Mate method. So uh, this will this is giving some error, so we can change it and we use the BFGS method. So method is equal to BFGS, or you can directly use this. So now it's working. It has no error. So we can just see the result. Again, it's giving the same result, but this method is appropriate for this data set. So you can just change the function if you want to estimate the parameters of, for example, normal distribution. You need two parameters, mu and sigma. And if you have different types of invasion, we need to optimize the different loss functions. Then you can use this method to optimize those functions. Thank you for watching. If you want to watch uh, such videos in future, you can subscribe my channel. Thank you.